Okay, so I'm very excited to give this talk because I was at the previous Illumos day, and I was brand new to the Illumos community. I was a complete newbie, and I was also just brand new to operating system development in general. Previously, I was working on databases. I was a senior developer at Basho on the React distributed database, and I had used SmartOS for about 2 years there. I think I was first introduced to it in 2012. And I liked it initially because of zones. So I still love SmartOS, and it's because of zones. And the reason I liked it is because I could take my development machine and stand up a bunch of zones very easily, and it looked like a distributed system for the purposes of functional testing. So that's kind of what drew me into Illumos. But then as I used SmartOS more and I talked to more people and read more things, I learned about the tooling. I learned about dtrace, MDB, and various things. And even though I only ever had a superficial understanding, I could see the power. Like the people that knew it well, I could see they could do amazing things. So this really drew me into SmartOS and the Illumos world in general. And then last year, before last Illumos day, I quit my job. And I did not quit my job like a normal person. I quit my job like a crazy person and just didn't work. And I took 6 months off. And I decided I was going to become an operating system developer. And so I came to Illumos Day maybe 3 or 4 months into that with the hope that I could find someone stupid enough to hire me with no previous experience. And luckily that worked out. Garrett Diamore, the founder of Illumos, actually was responsible for hiring me at a place called Lucera Financial Infrastructures. It's the easiest way to describe it is AWS for finance. That's butchering what we actually do. But we basically have a bunch of machines in the actual finance data centers with direct lines to all the important people, so it's very low latency. And we have compute and SDN and all this other stuff. But the relevant part for this talk is that it all runs SmartOS. And they hired me. Initially, I was going to be Erlang because I have Erlang experience, so initially they wanted me to work on FIFO, which is like an administration thing for SmartOS. They wanted me to work on that half-time and work on the kernel half-time. And I basically bucked that real quick, and I basically spend all my time as a SmartOS code janitor looking at performance issues or crashes. And I'm also the LX brand guru, so to speak, because we're big fans of LX. So that's my story, and that's why I'm very happy to be here. This is just kind of amazing for me because it's only been a year, and now here I am giving a talk. But as a newbie, as I still consider myself a newbie, I wanted to give a talk that was focused on people who are new to the community and they want to get involved in development. So what I'm going to talk about today is fixing bugs in Illumos, basically the path you take from finding a bug or looking at the bug list and debugging it and testing it and fixing it and the process you go through to get your code into Illumos Gate, which is our repo of record. So we're just going to jump. Oh, does that looks kind of wavy? We're just going to jump right into this and look at a bug. Is it okay? Okay. Yeah, so we're going to jump right into it. So this is a screenshot of the Illumos bug list. And I just picked one. Actually, I searched for a while, and then I decided on this one because it looked like a good one to demo. And just a note, when I'm looking for issues, I tend to go, for one thing, there's something called a bite-sized issue and the difficulty. I have a little beef with this whole bite-size classification because I think it's a subjective bite-size. Like, for example, this is about ZFS, and Matthew Aarons is a ZFS expert, so of course he labels this bite-size. I look at it and I'm like, what the hell is going on? And it takes me, an hour just to figure out what he's saying. So that's one thing. But the other thing I like to do when I look at issues, and this is just me, I like to look for the older ones first. I have a bit of an OCD with backlogs. I don't like things that just linger around. This issue itself is 4 years old now, number 1869. I think we're at like 6,000 some now. So I like to look at the old ones because it just makes me feel better, and I just feel like they're the forgotten souls of Illumos. So, and plus you get less chance if someone else is going to pick it up on you, right? Like I don't think anyone fights over issues, but if you're looking at an old one, there's less chance that someone's going to like fix it while you're working on it, and then you feel like you wasted your time. Although you didn't because you learned something, but you'd like to work on something that someone else isn't fixing at the same time. So for this particular issue, it is ZFS holds is O(n) squared. And for anyone who forgot their computer science or didn't take it, which is fine, n squared sucks because basically what it's saying is for the size of your input, the runtime is going to be square in relation to that. And in the description, Matthew says, ZFS hold snap is O number snapshots listed squared. For every snapshot, it gets all the holds on all the named snapshots. This can be observed with truss. The problem is that when the Python code was removed, it was replaced with incorrect C code, which calls ZFS for each for every argument, but ZFS for each iterates over the arguments itself. Now, this is a perfectly fine description, but I read this like 3 times. I'm like, I have no freaking clue what the hell Matt's talking about. You know, obviously, he's a ZFS expert. He's familiar with the command, and I'm not. Like, I believe what he's saying. I believe he's correct, but I just don't have the context for it, right? And it looks like once it was Python code, and it was turned to C code, and someone just didn't understand the interface of ZFS for each. So the first thing I like to do when I don't understand something, right, is first off, I didn't know what a hold was. I've used ZFS for a while. I'm not a ZFS expert, but I had no idea what a hold was. So the first thing I do is I go to the manual page, and I want to figure out what the hell a hold is. So the documentation says, list all existing user references for the given snapshot or snapshots. So for those of you that don't know ZFS, just really quickly, a snapshot is a way to take your current state of a file system. And in ZFS, a file system is almost like a directory in any other file system. And you know, you might have a state that you like, and you want to say, all right, I want to take this point in time, and I want to put a tag on it, and so that I can come back to it later. You know, you might roll back to it later, or maybe clone it or copy it later. And that way, you have that state, and then you can continue writing to that file system, but you have that reference saved, so you can go back to it if you want to later. But the problem with this, if you have a multi-user machine, right, you have multiple different actual humans that work on the same machine, and you take a snapshot, but then your buddy, you know, he's like cleaning up, you know, to save disk space or something, and he sees, you know, some of these snapshots lying around, he just goes and deletes them, you know, you've all of a sudden lost something that might be important to you. So what a ZFS hold does is it says, all right, I have a snapshot, this snapshot's important to me, at least for right now. I'm going to put a hold on it, and you can label it with a tag, and it's also going to list the username that did it and the date, and it's basically saying this snapshot's important to me. If someone tries to destroy it, they're going to get an error saying you can't destroy it because there's a hold on it. So then they run this command, and this command's going to tell them, all right, what holds are on it, who owns them, and now I can go talk to them, and we can discuss this. Or they cannot; they can just destroy it anyways. But they at least have to destroy the hold first, and then the snapshot. So it's just a nice safety net. Let's see, remember. Okay, so let's demonstrate. So now I know what a hold is. So now I want to see it in action. So I can first off, I'll make a file system. And then I'm going to just run a script I made to create a bunch of snapshots and holds. So I'm making 6 snapshots with a hold on each of them. I just don't want to do this by hand because it'll take too long. And then, let's see, what do I do next? Right, so then I can list the snapshots. Oh, can everyone see this? People in the back, can you kind of see the text? Okay. So, all right, this lists the snapshots. So I have 6 snapshots on this file system. And then I can pipe that with xargs and the ZFS holds. So I have 6 snapshots, and each of them have 6 holds on them. All right, so, and the behavior we're looking for is an n-squared behavior. So we're looking for the number 36 to appear somewhere. And in the ticket, Matt mentions something about truss. So let's just run truss on this and see what happens. And for those of you that don't know, truss is a way to trace the system calls that your application makes. If you're familiar with Linux, it has strace, but truss is better in terms of performance. It's less overhead. It doesn't use ptrace. And also, truss is more powerful because truss not only will trace system calls for you, but it'll trace user calls. It'll trace signals. It'll trace machine faults. You can whitelist things to trace. You can blacklist things to trace. You can gather statistics. You can deactivate or you can stop and detach from a process on a given event. So it's actually really quite powerful. You can do a lot with truss that you might have used dtrace or something else for. So it's a great starting place if you've never really done any debugging before. And the other reason it's great, just in general, is that the system call layer, that's the interface between your user application and your kernel. Anything important that your user application is doing is going to have to go through this layer. So by looking at this, especially if you're new, like I am, to operating system development, it kind of gives you a feel for what the hell your applications actually do. Even if you don't understand a lot of this at first, it's something you can come back to and study and be like, okay, how do programs actually work?
That first batch of open and stat64 or the map object, that's all the dynamic linker.
Right, correct. Yeah, so there's a bunch of stuff going on here, yes. I was just going to point out something even more simple. If you know OS stuff at all, you know that for a process to happen, for a process to occur, to come into life, there has to be two things: a fork, which copies a process, and then an exec, which overlays the new image of the process, and that's the new code that's going to run. And so the first thing we see is the exec for our sbin ZFS. And then there's a bunch of stuff that happens. For example, here we can see, well, there's a resolve path, and here we can see an open for libumem. That's the user space slab allocator in illumos. And basically, it's opening up this library to link it in because a lot of the commands in illumos use libumem. And then we got just a bunch of stuff that happens, and then we get to the more important stuff, or the more relevant stuff here, where we see a bunch of ioctls done by ZFS. Now, I don't know what any of these do. I don't know ZFS, but I can look at this and say, all right, I see a ZFS ioctl get holds. If I was a betting man, I would imagine that get holds takes a snapshot and just returns the holds, right? That's the most obvious behavior. And the other thing I notice is it looks like get holds is called 6 times here, right? And then this other ioctl is called, but then get holds is called 6 times again, whoop, and then it looks like 6 times again and 6 times again. And so it's looking like we're getting our n-squared behavior. So that's a really nice start. But then the next thing I would do is then I'm going to look at the code. I want to get a better, so I don't know what the octal does, but Matt gave us 2 references to the code, and I want to explore that code and see what's in there. Most of the commands, they live under user source command, and then ZFS is obviously under ZFS. And then if we look here, we have a few files, and ZFS main looks like the guy we want to look at. So we open that up, and then I'm just going to search for holds. And then I'm going to see this is ZFS do holds, so then I'm going to search for that. And I see some structure. This looks like some call table or usage or something. I'm just going to pass that. And then now I'm at the function, the actual, the meat of the implementation. And then remember, Matthew said something about a for each, so then I'm just going to search for that. And so here I see a ZFS for each. And there's a few things I noticed right off the bat. And one is that it's passed an argc and argv, which are the actual arguments passed to this function. So for whatever reason, the arguments themselves are being passed directly to this helper function, which seems a little odd. And then on top of that, it's in a for loop on, that is looping over the argument. So it looks like we have a for loop going over the arguments, then calling another thing that also does a for loop over the arguments. So now I'm curious, what does ZFS for each look like? So now I can go into a build environment, which I'll explain later, and then I can use cscope. Got to go to user source, and then I can use cscope to search, because I have no idea where this function is defined. I could use grep, but that's wasteful when I can just use cscope to go exactly to the definition of ZFS for each. And then I want to see, what does it do with the argument vector? Right, so here I see another for loop against the number of arguments, and then I see it doing something with a path to z handle with each argument. So this is looking like 2 for loops, like the n-squared behavior I was seeing. And then furthermore, I can see this comment down here that says, at this point, we got our AVL tree full of ZFS handles, so iterate over each one and execute the real user callback. So there's some user callback getting executed. And if I go back to the for each, I see this holds callback. So that's the meat of what's actually happening. And if I go up, I can see this holds callback definition. All right, so I have this information, and now I'm just like, I want to go back to truss, and I want to reduce the noise, and I want to see the n-squared behavior very clearly. So I can say, I can blacklist tracing all system calls by passing t. So t is the list of system calls you want to trace, and then the exclamation mark is saying blacklist them. And then I can say I want to trace certain user calls. A-out refers to the command the program I'm executing. And then I can say trace holds callback and ZFS for each. All right, and that looks right. And then I run that, and so this is a lot cleaner to look at. And sure enough, we see ZFS for each get called. It calls holds callback 6 times. And then ZFS for each gets called again another 6 times. And this is totally looking like the n-squared behavior. In fact, I can do one better. I can just count statistics, and 6 and 36. So there, we have a smoking gun, right? That's without a fraction of a doubt, we have n-squared behavior. So So that's cool, but just some other fun stuff to do while we're here. I didn't really do this when I was looking at this bug, but this is kind of fun to demo. So I can replace the lowercase u with an uppercase u. And what this is going to do is it says the first time you hit this function, I want you to stop the process and detach from it. So right, we see all the output, and then we see the holds callback, and then it looks like everything disappeared. But it didn't disappear. It's still there. It's just waiting. It's waiting for someone to attach to it and do something to it. So now I can use this great set of utilities called ptools to inspect this process. So I can use pfiles. I can see the files that are open, right? I can see my 0 is your standard in. Looks like it was mapped to dev null. You can see your standard out, your error, some pseudo device for ZFS. I don't know what the hell it is. Doesn't matter. It's cool that I can see it. And so you get all this cool information. One of my favorites is pstack. This shows you the stack of all the threads. There's only one thread. And another great one is pmap. When you want to see the address space of your application, you can see what addresses everything is mapped at. We can tell it's a 32-bit process because the addresses are small. You can see the size of every segment. It'll tell you, is it stack, is it heap? Up here we can see the actual executable mapped in. You can see all the user libraries mapped in. So this is just a really great way to kind of understand what is your process made up of. And then, since Dan McDonald is in the audience, I have to show this command. I don't use this one too often, but Dan raves about it, and that's the pwait. So I call pwait, and it's just waiting there, right? It's blocked. And then I go into another window, and I can say prun, pgrep cfs, and then that kicked the process and told it to start running again, and then we see the output, and now it's gone. So ptools is a great tool for exploring very easily. So basically, that's my favorite part of illumos is the tooling. This is what's drawn me to illumos more than anything. And some of the common, these are not all the debugging tools, but these are the most common ones I use. Truss I just showed, ptools I just showed, MDB we are now all very aware of. But for those that are watching the video, MDB is really cool because you can do postmortem core dump analysis. And my favorite is the live kernel inspection. The first time I did MDBK, I was both scared and felt like God at the same time because I could actually see what my kernel was doing live, but I was afraid I could also screw something up. It turns out, no, as long as you don't use MDBW, as long as you don't write anything, I think it's pretty safe. You're not hurting anything. You're just inspecting state. But it is really cool. I mean, you can just inspect all kinds of stuff and just do all kinds of crazy things like print the proc T of a given process to inspect what's going on. But my favorite tool and the one that I will not run any operating system without this tool is dtrace. It is the best debugging tool ever made, at least up until this point that I know of. And I refuse. I freaking refuse to run on any operating system. I'm forced to use operating systems that don't have it, but I get really mad. And you just have to have it, and it should work. It's crazy that we live in a world where dtrace isn't everywhere. So I wanted to make a dtrace demo for this, but the screwed up part is my favorite tool, and I actually had a hard time, because I wanted it to be a demo on the actual issue I'm solving here, but there's some things that made it a little hard. It had to do with the PID provider and just esoteric, so we're not going to get into that. But actually, it's really hard to describe dtrace to people and for them to really get it, because you tell people, yeah, dtrace is great, and they're like, yeah, I've heard the stories, I don't care. So it's better if maybe you just read some examples. So last year, I wrote a blog post called How My Printer Caused Excessive Syscalls and UDP Traffic. So I have a SmartOS box at home. I run it headless mode, and that's how I do my development. And one of my favorite tools to just health check a system is VMstat. That's the one I just go to first. I can't tell you how many systems I've found where they're doing millions of syscalls a second, and it wasn't because it was busy. It was because some process just went nuts. And so yeah, I always go to that first. And one day, I get on my SmartOS box. I just booted it up. And I noticed VMstat showing 35, 40,000 syscalls a second or something, which is not a lot, but I was like, why is it doing that if nothing's running? So I used dtrace and a few other tools, and I find out there's this MDNS program just going apeshit on my box. And I'm like, what the hell is MDNS? And I do some searching. It turns out some fucking crazy shit Apple wrote, and it's multicast DNS or something. And then I look on my OS, so this is all on my home network. I look at my activity monitor for OS X, and I see 270 million packets were sent in like the last 2 days. And I'm like, what the fuck is this? And it turns out my printer had been making beeping noises a few days before, and it turns out what happened is it all uses MDNS, and apparently the printer went into some crazy hot loop, and it just turned into a UDP Gatling gun, and it was just spraying packets everywhere, just nonstop. So sure enough, I turned off my printer, and I verified on my SmartOS box, everything went to normal, and I'm like, so that was kind of cool. Another one, so this is the blog post that inspired me to write the blog post I just talked about. Brendan Gregg, who is basically, if you don't know about Brendan Gregg's stuff, you need to look at that. Like, I just cannot stress enough, the work he's done, his body of work is amazing. He's one of the foremost dtrace experts. He wrote literally the book on dtrace. He does great stuff. And I remember this when I had first started using SmartOS, and someone, I think Scott Fritchie, who I worked at Basho, is also a dtrace fan. He sent this to me. And I remember at the same time, too, I had the same problem. So Brendan, he's on his MacBook, and he's doing something, and all of a sudden his keystrokes start dropping. He's like, what the hell? Like, why am I losing keystrokes? Like, literally keystrokes is disappearing. And so he breaks out dtrace and starts looking at it. He makes his pretty little flame graphs that everyone loves. And he finds out it's related to some like GUI task or some shit, running, and it's just going nuts. And it turns out it was related to the Wi-Fi. So when he disabled the Wi-Fi, everything went back to normal and he could type again. So as long as he didn't want to be on the internet, he could type. So he did all that with dtrace, and that was just amazing to me. When I saw that, I didn't pretend to fully understand what he did there, but I was like, all right, he was able to do all this just with dtrace. I'm like, that's amazing. But the best one, without a doubt, is shouting in the data center. And if you haven't seen this, you have to see. This is the first thing you do after this talk if you have time. Go watch Shouting in the Data Center. I'm not going to tell you what happens because it's much better if you watch it. But just know that what they did here was powered by dtrace. So go check it out. If anything's going to make you a believer, I think it should be that video. OK, so we have our bug. We've diagnosed it as best as we can. And now we think we have a fix. We want to fix the code. But before we can fix the code and make a patch, we have to have a build environment set up. But before I do the build environment, just a little explanation of what you're going to experience. So illumos came from Open Solaris. Open Solaris came from Solaris, right? So way back when Sun open-sourced Solaris, it was called Open Solaris. That thrived for a while. Oracle came in, killed all that. And then now we have illumos, which is the fork. And as Dan already kind of mentioned, illumos is not Solaris. Like if you say that around an illumos developer and you see their eye twitch, it's because they are not the same thing. A lot of people think it's pedantic, but it's not. They are two different things. But anyways, even though it's not Solaris, a lot of the people who used to work on Solaris from Sun surround illumos, right? So what you get with that is their traditions and their nomenclature carry over. And they have a lot of weird terms, or at least they were weird to me at first. I still think they're a little weird, but whatever. Everyone has their own terminology, and there's nothing wrong with that. But it's going to be confusing at first, right? You're going to hear things like, on and putbacks and gate and all this crap that you have no idea what it means. It's decades of history, where they came up with these things. And at first, I got frustrated, and I wanted to criticize it, and I wanted, to change things. But that was just me being naive. Now, after experiencing it and getting used to it, I actually prefer a lot of how they do things, their process. And I have no problem with the nomenclature anymore now that I've learned the terms. So it's just a matter of learning. It's just a matter of patience. And I would say if you're just jumping into this and you find it frustrating, just give it time. Give it 6 months, and if you still don't like something about the process, then maybe speak up. Because I noticed a lot of my qualms, I don't have them anymore because I gave it time. And another thing, I wrote a blog post called My First Illumos Build, because my first build took 30 hours to do. Not runtime, it took me 30 hours to do it because I kept screwing up. And I was following the directions on the Illumos wiki. They were mostly right, but there were little gotchas. So what I did in response is, for one, I wrote a blog post that explains the nomenclature, so you'll understand what the hell people are saying. But I also made a script called Nightly Setup that will do all the previous setup before your build that you need to do. It'll pull all the packages you need. It'll pull down the code. It'll set up your environment file, all the stuff that you need done so you can just build the damn thing and be on your way. OK, so now to actually set up your system, I recommend OmniOS. I'm not actually saying that because we're at an OmniTI sponsored event. I love OmniOS. I mean, SmartOS is my number one because I love zones and I do a lot of stuff with SmartOS. But if I wasn't running it, I'd be running OmniOS. And some people wonder what the difference is. The main difference is that OmniOS is more of like a traditional server environment where SmartOS tries to be more like a hypervisor, right? So they serve two different needs, but they're both great operating systems. And I think it's great that they both exist, not that there should be a single one to rule them all. But OmniOS, thanks to a lot of great work by Dan McDonald, a lot of hard work on his part, is able to build Illumos Gate now, which is huge, because before you always had to use Open Indiana, and I prefer OmniOS, so I'm very thankful to Dan for doing that work. And the way I run OmniOS, a lot of people probably think I'm crazy. I run OmniOS on a SmartOS KVM. That's how I build Illumos Gate. And I can build everything and lint in 44 minutes, so whatever, eat me. I don't care. i7. Actually, it might be 54 minutes. It's either 44 or 54, I always forget. But, oh yeah, I go fast. 3.6 maybe. Oh yeah, it's got good clock. Yeah, and I'm pretty sure I turn all sync off and all of that. I'm freewheeling it. So that's how I run it, but I don't recommend that, especially if you're not familiar with SmartOS, because it's a whole other thing you got to figure out. So I recommend if you have a spare machine laying around, use that, or if you have VMware Fusion, use that. VirtualBox probably works too, but I haven't used VirtualBox, so whatever. But if you do use Fusion, just a note, set it to Solaris 10 64-bit, and make sure you add a floppy, or else your installer is going to cry, and you're going to cry, and it's not gonna go good. And the link at the bottom is the note on adding the floppy, so everything works right. Okay, so you have your environment now. The first thing you have to do is zero it out, like you would zero out a weight scale. Just make sure you can build Gate without any modifications. That's the first thing you do. Don't go in there and change code and then try to build it. Build it once first, just to make sure you can do that and save yourself a lot of pain. And like I said, use my nightly setup script to set it up, and that way you're not going through the pain I did of trying to follow the instructions and maybe getting something wrong, and then you're sitting there fighting a build when all you want to do is just run it. And so here's the steps for my first build. Basically, take my tool, or take my my archive with the tool in it, and unpack that, run the nightly setup, and then all the code's going to be under code Illumos Gate. And then the one thing I would do for your first build is I have this little sed line here, and that's just to pull the lint option out of nightly options, because lint adds a lot of time to your build. So if you're on a slower machine, it could take over 2 hours to do a full build. Without lint, it might take more like 30-some. So you don't have to do that, but I would. And then you just run the build. So it's just a matter of running this nightly command, passing it environment file. Now, of course, you're going to be interested in if it failed or not. That's why I have this echo line at the end here. So it's very explicit. Either this thing ran or it failed, and I have to check the logs. And so what happens is there's a log directory created, and underneath that log directory is a timestamp directory for each build. And there's 2 files in that timestamped directory: the mail message, which is a summary of your build, and the nightly log, which contains all the output. And that's the more important one. If you have a failure, you're going to open your nightly log, and you're going to grep for 3 asterisks. And you're going to focus on the first error. Do not bother with any errors after that. I mean, you can if you want to waste your own time, but more than likely, errors after the first error were caused by the first one. There was a ripple effect. So just focus on the first one. And if you can't figure it out in like 30 minutes, I highly recommend going to the Illumos channel. They're very helpful people. As long as they're around, it's generally really fast feedback, and you'll figure out your problem a lot quicker. Okay, so this is getting back to the nomenclature a little bit. RTI stands for Request to Integrate. This is basically the name for a pull request in the Illumos community. And the thing is, though, it's a little more involved than like a typical GitHub PR, which is good, right? It's not like all loosey-goosey, like, oh, I got some change, and it's 3,000 lines of code, and it should just work. And some guy's like, yeah, this looks great, +1, and they don't really like properly test it. And RTI is much more thorough. One thing you'll notice about Illumos Gate is there is only one branch, and that's master. There are no maintenance branches, anything like that. When it goes in, it better be right? And that's on the reviewers and the approver to make sure that the reviewers did their job. And that's one of the things at first where I was kind of like, that seems kind of crazy. But then you look at the review process, and I'm like, okay, this makes sense. So 5 main steps in the RTI. First, you code and test your change, and you're going to want to use incremental builds, which I'm going to get to, because it's going to save you a lot of time. Second, when you're satisfied with your change, then you do a full build with lint, and you perform what's called an ONU, and I'm going to get to that. And then after that, you run something called PB check, which is going to verify basic style, like your C code style, your header style, all these various things. And then fourth, you submit what's called a web review to the developers list. And they're going to give you feedback. And then you're going to do this loop from 4 to 1. You're just going to go back and forth as you get review from the developers. And eventually, they're going to run out of things to say, and everyone's going to reach consensus, and they're going to like your patch. Or maybe not. Maybe they'll bike shed it. Some things get bike shedded, and it ends up in some weird abyss, but that happens. But most of the things, they just go through 1 through 4 a few times, and consensus is reached. And then at that point, you make an RTI, and you send it to the advocates list. So let's look at this in detail. So first off, when you're coding and testing, incremental builds. You want to embrace incremental builds. When I first started, I was like, I don't know why, I just had this weird fear of incremental builds. It's maybe just because I just didn't understand it. I was still learning the tooling, and I would do nightlies all the time. And it would just, the problem with that is, though, you make like a small change, and then you wait 30 minutes for nightly to finish. Then you test your change, you still screwed up. It's just horrible feedback. Incremental build allows you to build just a portion of the gate that you're changing, and you can even test it without building into the new environment. So it's really helpful, and it's a good way to get really quick feedback. But you have to be in a build environment, so you have to use this tool called BLD ENV, which I'm going to talk about in a little bit. And yeah, it's really simple. You basically you change directory into the part of the tree you want to build, and you say dmake lint if you want to lint it, or dmake install, and it's all really simple. Now, when you run dmake install, though, what's actually happening? Because you have a live machine you're on, right? I'm running Omni, and it's got its own kernel and system libraries. When I run dmake install, I don't actually mean install it on my host system, because I don't want to. If I made a bug, I don't want to like overwrite one of my libraries or whatever. So in the tree, there's something called the proto area, and every time you build something, the artifacts are placed in the proto area, right? This is kind of the staging area to build the actual kernel and the packages that you're going to create the new operating system from. And the other nice thing about the proto area is you can actually test certain things from here. So if you do like a manual page change, or if you just change a command like the ZFS command, or even some libraries, you can get away with just testing them directly from the proto area, and this will save you some time. But if you start changing like certain system libraries, or like the system call, or something in the kernel, then you're going to have to do what's called an ONU and actually boot into the new kernel to test it. All right, so BLD ENV, so build environment. This puts you in an interactive shell with all the proper environment variables set up based on your environment file. And this is what allows you to do those interactive builds and build the cscope index, which you're going to want. And I think, I'm not sure if I'm 100% correct on this. The only gotcha here is you need to at least do one nightly run to have the build environment for that to work. That may not be true, but I could have swore I read it somewhere, and I haven't bothered to try otherwise. But anyways. Okay, so it's okay, yeah, because, okay, build-m is one of the ones I haven't studied, so I didn't know what it actually did.
There's another way of doing it too. If you don't need to build cscope, you can use the WS command. That and build-in need to be merged and put into one good tool.
Yeah, I haven't used the WS command yet either. I'm showing like the very basic, like, yeah,
Okay, WS needs
right. I'm giving the newbie. Right. I'm giving the newbie approach here. Anyways, so cscope. Cscope is a great tool. Embrace it. When I first found out about cscope, I'm like, how the hell did I not know about this tool before? And I like that it's built into the gate. So you just go, you go into a build environment, you go into user source, and you say dmake cscope out, and now you have an index, and then you say cscope fast dequeue. And you can search, it's great, you can search for symbols, you can search for where functions are defined, search for functions that call a certain function, you can search for where certain variables are set. Like, it's just really powerful and saves you a lot of time, and it's much better than using grep. Oh yes, yeah. I mean, it's an open source project. I've used it on other things, but I like that it's all built into Gate too, so you don't have to like think about how to use it, which is great. Okay, so you've done your incremental build, you've tested it and all that, and now you want to put a web review out there, and you want to make sure the whole thing works together. This is where you're going to run nightly. So nightly, kind of weirdly named, because it's like, well, I'm just doing a full build. Why is it called nightly? Well, probably because whoever first wrote this, it was based on a nightly batch job. And this is just a holdover. But yeah, this is what you run to do a full build. And actually, an excerpt from the manual page, which I'm just going to read here, is the advantage to using nightly is that you build things correctly, consistently, and automatically with the best practices. So the whole point of this is just to make sure we're all building the same way, which is vitally important, because if we all just like built on like if there were just instructions on a page, like some of us would do it differently, or we'd miss a step, and there would just be all kinds of chaos. So this makes sure we say, did you run a nightly? Where's your mail message? So we know how you built the system, and that's vitally important. It builds ON, so I didn't realize Dan was going to cover all this like terminology, but ON is basically OS network. It's what is in Illumos Gate. It's just the old name for it, and that's what Nightly builds. It builds that, the kernel, all the system libraries. It builds the packages for you. And you need to use Nightly for two reasons. You need the mail message to RTI it. That needs to be included. And you should always do a full test of ONU, except maybe for like minor changes. You should always ONU just in case, because IPS, the packaging system, goes a little bit crazy sometimes, and you think like something like, or you don't realize that you changed something that requires a packaging change, which I recently did, and Dan rightly pointed out to me. So it's always good to run it and make sure you didn't actually break anything with IPS. So the environment file, illumos sh. So this is used to configure Nightly and build env. It's basically your customization of the build environment. The only thing you really have to worry about when you're starting out is Nightly options. The rest of it you can forget, especially if you use my Nightly setup script. It'll take care of this file for you and just do the right thing. And you can just change Nightly options when you want to control the steps that are taken by your build. And then over time, as you get more advanced, you can delve into illumos sh and figure out what the different things do. Okay, so BEADM stands for Boot Environment Administration. Boot environment is basically the OS you boot into. BEs allow you to have multiple instances of your operating system that you can jump between via system reboot. And it's basically so you can perform safe atomic upgrades of the kernel and the system and the user applications. Basically, you can safely upgrade the entire OS, right? So this is in contrast to something like Linux, where if you're on Ubuntu or something and you do a system update, whatever, I forget the command, the apt upgrade world or whatever the hell it is, and it's a destructive action, right? You might get halfway through and something fails, and now you're left with a machine that's completely shit. It's just bricked. Luckily, if you take backups or something, you can recover it. But it's really stupid that you should have this problem. And of course, and I don't know if anyone knows about Nix OS, which they're all about like functional programming and like we version everything and put everything in its own directory, and you take snapshots of everything, you can roll back. Basically, BEADM could do like a lot of what Nix OS does, and it did it years ago. Just another example of how I feel like that the Sun people really, they had vision. And yeah, so this is great. So you build your new kernel, and then BEADM, you can use that to build a new environment using that kernel, and then you can boot into it. And if you don't like it, if something's broken, you can boot right back into the old environment. And that's all done with this tool. All right, so ONU, I said this a few times now. This is ON update. So this is how you update the kernel from a build. So you make your build, and then you run ONU, and it's going to take your new packages, make a boot environment, and then activate it so that when you do a reboot, you're going to be in the new kernel you built. All right, so the third step is PB check. This stands for put back. Once again, another term. I have no clue where it came from, but they like to say it. So it's a put back check. And basically all it does is it's stylistic, right? It verifies your commit format meets a certain standard. It verifies your illumos C style as best as it can. It's not perfect because it basically just uses a bunch of regexes. But it does that. It verifies header format, and it also checks your copyrights. So the nice thing about this seems like a weird tool to have maybe, but I think it's great because you end up getting the same C code style across the board. To me, that's the most important point, is that when I look at code, I don't see different stylistic code in the source files, which is awesome. Okay, and so for the fourth step is your web review. WebRev generates a standalone web page showing you all your changes, and it's cool because it generates them in all these different diff formats because people have different preferences, and they might prefer one format over another. And recently, thanks to Yuri Pankov, hopefully I didn't say his name wrong, he added this nice feature where manual pages both have the raw diff and the generated diff, which is great because reading raw, nraw for whatever the hell that is, or mdoc is just freaking horrible. And in fact, just really quick, just to show you what that looks like, for example, this is a big thing I did recently for the on-build tools because they were in the wrong section. So I basically made small changes to a bunch of man pages. If you look at like the raw diff, so this is a small change, so it's not a big deal, but imagine like a real change, like this is gonna get really ugly. Or you can do it this way where you can see, oh, this is the actual texty change, right? It's a lot easier to see it, to review it this way. So that was a great little feature that was done. And finally, after you've gone through all this, so you've gone through review and you go through that cycle, you're finally going to submit your RTI. And one point to make here, at first you might think it's weird that, so you'll have approvers, right? You're going to have multiple people that approve your code, and then you're going to have a separate person, you're going to have multiple people that review your code, and then a separate person that approves it. And I think the reason they do this is that it separates concerns. So there's people who are responsible for reviewing the code, and there's a person who says, did these people who reviewed it, did they go through the appropriate process? Did they take the proper steps for me to allow this thing to make it to gate? And it kind of removes those two roles, which I think is a good thing. And anyways, so the RTI email is basically a list of reviewers, so the people who reviewed your code, a summary of any testing you performed, a copy of your PB check output, a patch file containing the actual change itself, a compressed mail message so they know you ran a nightly build and it ran without fail, and any additional information you wish to share with them. Okay, so going back to this bug. So Dave already kind of showed MDB, but for people viewing this video, when I was fixing this bug, I made a couple of mistakes the first time around, and I actually generated a core file, and I just wanted to show how you might do a just basic post-mortem analysis. So I generated this core, and I want to look at the stack. So I see my ZFS, I see the holds callback called, and then I see string compare called, and notice the 0 in the first argument. So I passed a null pointer to string compare. It's not going to like that. And obviously, this seg faulted. But before I show you why that happened, or actually, I'm not going to show you why it happened, but before I move on, I'm going to show you can actually. So I know the first argument to the holds callback is a ZFS handle T, and I can actually take the address that was passed and use this printd command and pass it the type, and it can print that out and show me a pretty print of that type that was passed in, which I just think is amazing. The first time I did this, I was like, this is just so cool. So that's really cool. And when I was debugging this, so I had 3 string compare calls in this function. So I'm like, well, which one is it? I can't easily tell. But I do have, so I have the holds callback, and I have the offset, that plus, BB. So I can take that, because that's an address itself, and I can disassemble it, right? And I'm not going to pretend like, okay, yeah, we have assembly, which doesn't help a lot, but I can see these calls to string compare. So I see the first one, and then I see the second one, I see the address I'm at. And what I know is, well, the stack is going to save the next address I return to, so I know that I was at the second string compare call. So I was able to look at that and go, oh, I got to look at how whatever I'm doing with the second call to string compare, and that's where my bug is. And sure enough, I did that, and I was able to fix the bug. So that's just a little demo of MDB. Right, where am I? Okay, and then, so I finally made the good fix. ZFS main good. Right, so I copy that, and I run dmake install. Whoop, I'm not in a build environment here. Wait, actually, I don't know if I had to do that, actually, but. All right, so I build my good version, and then I'm just going to copy this so I don't type it all out. Now remember, before it was 6 and 36, and now if I run it, notice holds callback is only called 6 times. So I fixed the problem. And then I made a web rev of that. And you can just tell quickly browsing it that this was way more involved than it should have been. And that's because there's a recursive option with holds, and it is just, I think it's completely broken. And I don't think it's consistent with other ZFS commands. I might find a way to simplify this, but I'm basically going to throw this over the wall at Matt and be like, I don't know, you do what you want with it. But yeah, so then I would send that, and people would review it. Okay, so to wrap up, Some must-reads. So my post, my first illumos builds, read that for the nomenclature, and you can learn about my nightly setup script, which I think will save you time. There's an illumos.org books URL, which contains a lot of great stuff. They have a MDB book, a dtrace book, and a development book. And the development book has a great page called Workflow that basically shows you the steps that I went over just now, but in greater detail. And it's always a great place to go back to when you're like, you have to remember, oh, what step do I do next? Come back to this page. That's what I did for a good 6 months. And so yeah, that's a great page to look at. And then there's the official How to Build Illumos page on the wiki. There's great information there. It might be missing a step or two. I actually need to update it because some systems you have to create like one symbolic link for things to work. But overall, these are the steps that my script is going to follow, but it'll do it all for you and make sure it's right. And then finally, the last link is the issues list, and this is the query for the bite-sized issues, the subjective bite-sized issues, so you can check those out. A lot of people ask, is Solaris Internal still relevant? I say, yes, it absolutely is. Now, people who know Illumos better than I do will say there is a lot that has changed, and they're probably right. They would know better, but I think the broad strokes are all there. And furthermore, even if this book wasn't relevant anymore, I have bought a lot of operating system books in the last year, this by far to me has some of the best writing and just examples, and I really prefer it to a lot of my other books, and I use it daily, so I totally recommend buying this book. And then finally, I just want to say that anyone can do this. I've always been a back-end developer type person, but I always thought I wasn't good enough to do operating system development. I just didn't I didn't take any formal classes on OS dev in college. I took one, but my teacher wasn't very good. It was a crappy class, and I just didn't think I could do it, and I just think that was a mistake. And I think if you're out there and you're interested in this, I don't think it takes a degree or any background in this. I just think the main things are time and patience. You got to have a lot of patience to do this. But you don't need any special genetics to do it. So I just highly suggest, if you're interested, to absolutely chase it. And don't let anyone tell you otherwise. And that's it. Questions? Right.
So, but get PB check. If it says nothing, everything's okay.
Right.
But I amuse myself with getting hung up on this.
Right.
Now I have to figure out what nothing meant.
Well, isn't that one of the Unix, a standard Unix thing where they say the command should not print out anything unless there's something like no unnecessary printing or some crap like that? Yeah.
Shell prompt print the exit code. It does exit code 0.
Mine does. Yeah. Right, right. It's a good point. Right, right. Congratulations, you didn't fuck up. Yes. Right, right. My regexes, my Perl script didn't catch anything. So. Right, and so for those that are watching the video, it was just mentioned that there's a review board for reviewing the code, which I did know about. I just kept it out because I just focused on the web rev for now, because I also prefer web rev myself. But review board, I think, can in some ways be better. You can follow the stream a little bit more easily, but yes.
Well, also easier to see when things have been reviewed.
Yes, yeah. Yeah, because things do get a little hairy. When you have a big review and it goes through a few iterations, and a lot of people will squash their last code change, it gets a little weird, and we could probably do better there. But for some reason, I come back to web rev. I'm I just like this. I don't know why. So, but that's a good point.
It doesn't stop you from doing both.
Yeah, that's true. You can also do both. Yeah, yeah.